All right, this is a pretty long section, so we'll see how much we get through today. But 2.5, complex zeros. And the fundamental theorem of algebra. So the first one's how to write the polynomial in standard form, identify the zeros of the function in the x-intercepts of its graph. So, 2, we have f of x is equal to x minus 3i times x plus 3i. So we're going to write it in standard form first. And then, oh wait. I wrote this problem wrong. Hold on. I'm just going to rewrite the whole thing. This is supposed to be reading the wrong problem. X plus 2 times x minus the square root of 3i, and then times x plus the square root of 3i. There we go.
It just got way more complicated.
Yeah.
Yeah, like the first one.
So I put it up there and I was like, this one's too easy. That just means you get to do the other one for homework, meaning you have an easier one for homework. So I could have given you this one for homework instead. All right, so I need to multiply. I would start with the two things that are like the same essentially, because they are difference of squares. So we would have x plus 2 times x squared minus
No, wouldn't it be plus?
no, these are opposite signs.
Yeah, but it isn't negative.
3i squared.
What?
The difference of squares. The middle term goes away.
Oh.
So we multiply the last one. So it is negative 3i squared. Obviously, I squared is negative 1. So if I want to, I could rewrite this whole thing as plus 3 instead. And then FOIL this. So I would get x cubed plus 3x plus 2x squared plus 6. Then I should rewrite it. So I have f of x is equal to x cubed plus 2x squared plus 3x plus 6. So that's part of what they asked me for. They also asked me to list the zeros and the x-intercepts. So how many zeros does this function have? 3. So the zeros are just changing the sign on each of these values, because this is essentially, if we set it equal to 0 and solve, that's what we would get. So my zeros are negative 2, positive root 3i, and negative root 3i. Now what about my x-intercepts?
-2.
What about the other two?
They're imaginary.
Yeah, they're imaginary, so they don't count. So the only x-intercept is negative 2.
When you say imaginary, does that mean that they don't show up at all, or is that just like we're not worried about it?
I mean, they're part of the function, but you don't. It doesn't look like the zeros that cross the x-axis.
So when it's graphed, it doesn't like appear on the line, basically. Or
1 second, I'll show you. That was not the right button. Zoom 6. So I have a 0 at negative 2, but then it just keeps going up. So you don't see them on the axis like you do, because they're imaginary. You're only going to see real zeros on a real graph.
Oh, okay. So, is there an imaginary graph? Is that the thing?
There's an imaginary axis, but it's different in how you do that. We don't do anything with that. Other than, last year we plotted some imaginary points in Algebra 2. But that's about it.
Showed me that it's like you can do a 3D graph with all three, and that shows all the zeros.
Yeah, but you don't need that for
How do you do that?
anything in what we're doing
And
at
put it
all.
on the graph and calculate it.
Yeah, your calculator doesn't do it for you.
You don't want that. It exists, but just because it exists doesn't mean you can graph it.
Yeah. It's like a third axis.
Like x1.
All right, write a polynomial function of minimum degree in standard form with the real coefficients whose zeros include those listed. But remember, if there's something where they don't give us one of them, we have to write the other one in. So number 8, -4, 1 minus I, and 1 plus I. So because we have 1 minus I, we also have 1 plus I. In this particular problem, they give you both of them. However, in some of them, like number 10 and number 12, they don't list both of them, so you have to know that you need to add them in to get to your right answer. Sometimes they tell you, sometimes they don't. So, these are essentially the zeros. So this is all like x equals whatever. So I need to move this stuff over to get my factors. So this is going to be x plus 4 times x minus 1 plus I, and then x minus 1 minus I. And then I just need to multiply. Again, I would do the two things that look relatively similar to each other because a lot of things are going to cancel. And if you multiply it not in that order, it's just going to make it a little bit more difficult. So I'm just going to bring down the x plus 4. And then I've got x squared minus x minus ix. And then I've got minus x plus 1 plus I. And then plus ix minus I squared. So before I do anything else, I would see if there's stuff that I can cancel out because most of the time there is. So I've got negative ix and positive ix. That goes away. I have a positive I and a negative I. That goes away. And then the negative I squared is going to become positive 1. So now I can simplify this to make it easier. All my i's are gone, just the main reason for doing it that way. And so I've got x plus 4 times x squared minus 2x, not 2x squared, minus 2x plus 2.
Isn't it just a difference of squares? Like x minus 1 is a and I is b. That's what I did and I got the same answer.
Yeah.
Okay,
No, you can do that. A lot of people get confused, so I don't ever show it that way.
I got you.
All right, so then multiply this. So we've got x cubed minus 2x squared plus 2x plus 4x squared minus 8x plus 8. And then simplify it. X cubed plus 2x squared minus 6x plus 8. So that's all you have to do on those ones is just rewrite them with multiplication. All right, so on all of those ones so far, the multiplicity has been 1. Okay, that means that's how many times that 0 occurs. But we're getting into the ones where they're going to give you a 0 and they're going to tell you what the multiplicity on it is. So that would just mean whatever we put in parentheses, we're raising it to that power of the multiplicity. So 14, I've got -1 with a multiplicity of 3. And then I've got 3 with a multiplicity of 1. So if they don't specify, assume that it's 1. But in these ones, obviously, they're going to tell you whatever they are. And again, if I had one like, well, am I going to do that problem or no? Well, I'm going to do 16, so we'll talk about that in a second. So this, again, is like x equals -1. So to multiply it, I have to rewrite this as x plus 1 times x minus 3. Now, I'm looking at the multiplicities, and I'm going to add that as an exponent. So on x plus 1, that's actually getting cubed, and then times x minus 3.
Why is it -3?
Because you have to change the sign on it. So I would probably recommend with a problem like this that you rewrite this as x plus 1 times x plus 1 times x plus 1 and then times x minus 3, and then group them in sets of 2. And then this first thing is a perfect square trinomial, and then you're just foiling this last part, but up to you how you decide to do it. So this would be x squared plus 2x plus 1. And then over here, x squared minus 3x plus x, so that's minus 2x, and then minus 3. And then just superfoil this whole thing. So I would get x to the 4th minus 2x cubed minus 3x squared plus 2x cubed minus 4x squared minus 6x plus x squared minus 2x minus 3. Simplify, or well, if anything cancels first, I'm going to do that. Minus 2x cubed and plus 2x cubed cancel. And then nothing else, just straight up cancels. What does it look like? So I've got x to the 4th. I've got no x cubed because those two things canceled with each other. My x squared terms are going to give me a negative 6x squared. And then my x terms, negative 8x minus 3. And that makes sense because if I add up the multiplicities of my zeros, obviously there were 4, so my highest power should be x to the 4th on that. I've got -1 with a multiplicity of 2. And then I've got -2 minus I with a multiplicity of 1. So that's all they tell me. But what do I know must be true as well?
-2 plus I is also 0.
Yep, -2 plus I also has to be a 0 with the same multiplicity. I don't always write multiplicity 1 beside it, but so then gonna set this up. So I've got f of x equals x plus 1 with a multiplicity of 2, so I'm gonna go ahead and square that. And then I've got times x plus 2 minus I, and then times x plus 2 plus, nope, this was supposed to be plus I. This one's supposed to be minus I. Doing them out of order, apparently. There we go. Plus 2 plus I plus 2 minus I. There we go. Alright, so then this right here is just a perfect square trinomial, so I'm not going to rewrite it. I'm just going to set it up. So this is x squared plus 2x plus 1. Then over here, we're going to just multiply everything through. So I've got x squared plus 2x minus ix plus 2x plus 4 minus 2I plus ix plus 2I minus I squared minus ix and plus ix cancel, negative 2I and plus 2I cancel, negative I squared turns into a positive 1. So I've got x squared plus 2x plus 1 times x squared plus 4x plus 5. Again, we just got to multiply it. Shepard must be ready for a quiz. X to the 4th plus 4x cubed plus 5x squared plus 2x cubed plus 8x squared plus 10x plus x squared plus 4x plus 5. Simplify it. X to the 4th plus 6x cubed plus 14x squared plus 14x plus 5. So obviously a lot of multiplying in this, but hopefully this stuff isn't too complicated. All right, so we're jumping down a pretty big chunk of problems to the next thing, which is find all the zeros and write a linear factorization of the function. So this would be essentially your linear factorization right here for a problem. So they're going to, basically we're working in reverse now. They're giving us this. We need to find the possible zeros, check which ones work, and then go all the way down till it's factored out as far as possible. So 28 f of x equals x cubed minus 10x squared plus 44x minus 69. All right, so I need to find all the zeros. How do I do that?
That's minus 69.
Yep. So then obviously I don't need to write, you know, everything over 1. I can just write it all out. So what are factors of 69?
1, 3, 6, no,
13. Or,
23.
What's the last one?
69.
I can pause if you need me.
How much longer do you have here?
I mean, I have quite a few problems left, but
All right, can I have you for 30 seconds?
yeah,
Thank you.
don't let my iPad go off. should have told y'all to be looking and figure out which one of these actually works.
Number 3.
Do you know that, or are you just guessing?
Guessing.
Because I wouldn't really want to do 8 sets of synthetic division if I don't have to.
Was that a good guess?
1 to
Why don't you put it in a calculator and find out? Everybody, not just Mason. Everybody.
Right. -3.
Oh, I was like, what is happening? There we go. All right, any other ones or just 3?
3.
All right, so let's check 3 and see. So we put that into synthetic. Make sure you watch in case any numbers are missing. We've got 1, -10, 44, and -69. Bring down the 1, times 3 is 3, minus 10 is -7, times 3 is -21, plus 44 is 23, times 3 is 69, minus 69 is 0. So one of the factors then is x minus 3. Okay, because we changed the sign when we put it into a factor. Now, are there any other places where it looks like it crosses? No. So that means that I know that this ultimately should have 3 zeros, right? They just don't all have to be real. So I need to find the other one. So this was x cubed. This is now x squared. So I've got x squared minus 7x plus 23. So if I have that, is that factorable? Good hint. If it doesn't cross the axis anywhere else, it's not factorable. So what other methods do I have to try to find the zeros?
Quadratic formula.
Quadratic formula, I could hypothetically complete the square, but most people don't like that. So I would use the quadratic formula. So negative b, which is going to end up being a negative number, so that's positive 7 plus or minus the square root of b squared, so 49 minus 4 times 1 times 23, all over 2 times 1. So I've got 7 plus or minus the square root of, was that 80? Nope, 92. 49 minus 92, is that right? 43. Negative 43. All over 2. So what happens in here?
Oh, put an I out.
Yep, take an I out. So I have 7 plus I root 43 over 2, or 7 minus I root 43 over 2. So those are my other 2 zeros, okay? So I'm going to be factoring them over. So this is x minus 3. So my answer then is where is it? F of x equals x minus 3 times x minus 7 plus I root 43 over 2, and another x minus 7 minus I root 43 over 2. No, because if you multiply it all out, you're going to get right back to where you started. Normally, they're not this weird looking,
Yeah.
obviously. They normally are nicer. Like 3i or 4i or something like that. Not like 7 plus I root 43 over 2. Like, that's just kind of chaotic. Um... 34. 4i is a 0. Of f of x equals x to the 4th plus 13x squared minus 48. And they want us to find all the zeros and write the linear factorization that we would get after that. So, if 4i is a 0, what also must be true? Negative 4i is also a 0. So I know 2 of them already. It means I only have to find 2 more essentially, but I still I have to use those to find them. So we're going to use one of these up here in synthetic for the first round. And then I have 1 x cubed is missing, so I put a 0. Then I have 13 for the x squared term. X is missing, so I also put a 0 there, and then minus 48. Bring down the 1 times 4i is 4i, plus 0 is 4i. 4i times 4i is 16i squared, or we can just write minus 16. And then plus 13 is negative 3, times 4i is negative 12i. So that's negative 12i times 4i. So that's negative 48i squared, but that would become plus 48. So 48 minus 48 is 0. Now, this was x to the 4th. Obviously, this is now x cubed. I don't have to do anything other than keep going with synthetic. So now I'm going to do negative 4i with the remaining numbers. So 1, 4i, negative 3, negative 12i. And I'm going to keep going. Bring down the 1 times negative 4i. Negative 4i plus 4i is 0. Times negative 4i is still 0. Bring down the negative 3. Times negative 4i would be a positive 12i. Minus 12i is 0. So both of those are obviously, well, 1, we proved that they're really zeros, and then 2, it's gotten us down to something that's easier to manage. This was x cubed, this is now x squared. So I now have x squared minus 3. And so then I can, set it equal to 0 and solve. So x squared is equal to 3. So then x is equal to plus or minus the square root of 3. So that's my other 2 zeros coming out of this. So write it as a linear factorization. I would have f of x is equal to x minus 4i times x plus 4i from the 2 zeros they gave us, or well, they gave us 1, we found the other one. And then the other 2 that we found after that, x minus root 3 and x plus root 3. And if you multiply all of this back, it'll get you back to your original function that you started with. But obviously we don't have to do that, we're just finding linear factorization, just showing you that. So if you want to check it, both of those are difference of squares, so it would be a relatively easy check if you needed to do that. All right, the last set of problems say to write the function as a product of linear and irreducible quadratic factors. So we're taking it as far as we can, but we want them to be, like, everything needs to be, like, real and all of that. So, 42. F of x is equal to x to the fourth minus 2x cubed plus x squared minus 8x minus 12. So fortunately, no missing terms on this one. Relatively easy because it's going to be over 1. So I've got plus or minus 12 over plus or minus 1. What are all the factors of 12?
1, 3, 4, 6, 12. 1, 2, 3, 4, 6, 12.
Yep. All right, so now plug that into your calculator and tell me which ones look like they might work.
-2 and +3.
-1 and +3.
Oh yeah, no, that's one.
Okay. Now, as soon as you checked it, you would know that wasn't right, and you would know to try something else if you had misread it or whatever. Because as soon as you put it in synthetic and it's not equal to 0, you'll know it's not right. So then you just have to start over. All right, so do you want to start with -1 or with 3? All right. So -1. Again, no missing terms, so I'm good. 1, -2, 1, -8, -12. So bring down the 1. Times -1 is -1. Minus 2 is -3. Times -1 is +4. Nope, it is not +4. It is +3. Plus 1 is 4. There we go. That's where my 4 is supposed to be. Times -1 is -4. Minus 8 is -12. Times -1 is +12. Minus 12 is 0. So I've confirmed that one works. So I like to usually go ahead and write over here to the side what the factor is, which the factor is x plus 1. I usually circle it so I don't lose it on my paper somewhere. I'm going to use the resulting numbers with 3 to check that one and make sure that it works. So I've got 1, -3, 4, -12. Bring down the 1. Times 3 is 3. Minus 3 is 0. Times 3 is 0. Plus 4 is 4. Times 3 is 12. Minus 12 is 0. So that one also works. So this factor is x minus, why did I write 13? X minus 3. So I'm left with x squared plus 4 essentially equals 0. But that means I'm going to have x squared is equal to -4. So x is equal to plus or minus 2i. That's a problem. That's not a real 0, so it's not what it wants us to do. So I'm going to leave this as a factor in and of itself as just x squared plus 4. Because they don't want, in this particular problem, they don't want i's and they don't want radicals. So my answer, f of x, is equal to x plus 1 times x minus 3 times x squared plus 4.
We don't break up the x squared plus 4 part?
Nope. Not in these ones. Normally, yes, but these ones say to write the function as a product of linear and irreducible quadratic factors with all real coefficients. So this one would be imaginary, so that's why we can't do it. All right, questions on all of this? Good. Remember it from last year, roughly. All right, problems then. And don't worry, you're going to have tomorrow to do these also. Three, 7, 11, 13, 15, 29, 33, and 41. So, if after doing those you feel like there's something you're still not getting or whatever, obviously you should do more. But if you feel like you've got it under control after those ones and the ones that we did in class, obviously that's fine. If you want to get started now, you can, but we only have about 10 minutes left. So, anyways. Tomorrow you'll also have time to do your 2.6 notes in class on top of doing this. So if you haven't done it, then whatever. If you do these tonight, then, well, if everybody does everything tonight, then we'll just start the next section tomorrow. But if you finish tonight and you're like, I need to use tomorrow to study, you can also do that. So.
Yeah, use the restroom.